Good afternoon and welcome to this next series of webinars online. It's entering 12 o'clock noon. So as every Tuesday, we are working from our offices in Leuven, trying to make at least the world a little bit more cyber secure. And today it's not going to be any different. We're going to work together with some of our partners from Microsoft to make that happen. So thanks very much for joining. The LSEC organization is a not-for-profit organization. It has been around for 2 decades. And one of our main activities is really to bring people together to work on different challenges in relation to cybersecurity, trying to focus on what is happening in the world, how the world is actually using new types of technologies that we then can figure out how to further secure them. And one of those interesting developments is, of course, happening in the world of the industrial space. And so already today, for the 6th time since the last couple of weeks, we organize our industrial cybersecurity activities from home with our cybersecurity experts also from home. And today's topic is basically an evolution of what we have been talking about before. We have been talking about risk management in relation to industrial context, in relation to manufacturing. We've been talking about the Network and Information Security Directive, namely the regulation that's actually requiring some organizations of operations of essential services, operators of essential services, to comply to a series of regulatory requirements in relation to cybersecurity. So following this, we have talked about how can an organization like a manufacturing company now really start on understanding what cybersecurity is all about and what they have to do in order to be able to comply to those types of challenges. And we have talked about the risk management perspectives. We have talked about some vulnerabilities on how big corporations are actually trying to cope with those challenges and the relations. And taking this to a next level, we see, of course, the evolution of the world. For instance, the world in relation to new technologies entering into the manufacturing world, such as, for instance, IoT, Internet of Things. Internet of Things technologies, as the word in itself says, it's bringing internet into a thing, into a device. And in the world of manufacturing, where there's a lot of machinery being used, that's of course bringing opportunities in the first place. It's bringing opportunities in terms of collecting data, collecting information from machines that we have never been able to collect before, using sensors and using intelligent capabilities of analytics, and storing those into big data vaults, and from there on, trying to make sense on how an operation of a manufacturing environment not only really works, but also how it can be optimized in many different forms and shapes. And so this is the reason why, of course, from a cybersecurity perspective, we're obviously also interested in that domain. So I'll share with you a couple of ideas on who we are and what is driving us to this. LSEC has been around for 2 decades and is what we call ourselves a digital security catalyst. We try to be a catalyst of digital security amongst end users, amongst providers of technologies, and amongst research organizations, innovators. We do that by bringing people together, in this case in an online fashion, but also in trying to help to innovate, understanding what the challenges and the opportunities of the technologies are today and moving forward. Tomorrow we'll have a new series of webinars organized on a weekly basis as well. And this one is specifically focusing on digital manufacturing transformation, where we will tomorrow focus on condition-based maintenance activities and bring together some use cases on that perspective. So how to use IoT for a specific industrial use case called condition-based maintenance. This is actually derived from some of the activities and experiences that we have ourselves. One of the LSEC activities is called TRIF, and TRIF, as we also call it, is basically there to support manufacturing companies in making that transition towards digital, with a series of tools, equipment like the ones that you can see, with a series of digital platforms, such as the one that we will be talking about today, the Azure IoT platform. We try to combine different provided technologies and showcase this on how it actually can provide a benefit in an industrial world, specifically, for instance, in this case, the world of manufacturing. And from this activity, from these experiences, we have derived our own joint venture activity, which is called Factory Sons, which is providing a business dashboard for small to medium-sized factories. So we use the different technologies and tools to create new dashboards for companies that before were completely non-digital. So with this platform, we actually showcase how on an intelligent basis, we can easily transform any analog processes into something digital. And this basically is in relation to what we do also on a European level. We seek into how the world of manufacturing is transforming. We call this pathways, and we have a project which is called Connected Factories. And through the pathways, we try to identify what the factories of the future are currently looking like, but also how they will migrate further towards the future. And in addition, and even more importantly, how companies can actually migrate from where they are today in level 1, 2, or 3, and how they can migrate towards level 4 and 5 of those pathways in terms of autonomous smart factories. We also have a couple of other activities in that space. Trinity is a platform where we are focusing really on robotics, but where we can also imply cybersecurity components for robotics and how to further improve robotics in terms of cybersecurity in itself. So with that, I'm happy to announce today here our friends from Microsoft, in this case, Bart. Hello, Bart. Good afternoon. How are you?
Hey, Ulrich. Very fine. Can you hear me well?
I can hear you loud and clear. So let's go over to you, and please do indulge us with what you within Microsoft are doing in terms of industrial cybersecurity, and then specifically, of course, focus today on what you have in terms of Azure IoT, and specifically what you can also provide in that level in terms of cybersecurity. So I'm going to hand it over to you. Let me stop sharing my screen. Maybe a short introduction about yourself. So you are now with Microsoft since a couple of years, but you've been in the security industry for quite many years.
Yes, indeed. So I started in November 2018 at Microsoft. While, of course, before a lot of years, I was already active in the cybersecurity space. I've been a customer pretty much all my life, and I think the last 8-ish years I've been transitioning from that customer, moving into the companies that really create cybersecurity, that are on the starting points and that also work within the vision and transformation of building cybersecurity solutions. And today I'm really happy to talk to you guys and girls what we can do from Microsoft to support a secure IoT business, because IoT it's a different kind of breed. Let me put it this way. There's a complete difference when we talk about cybersecurity, and including modern workplace or servers or the cloud. And then you got IoT. Now, let me know if you can see my screen.
Yes, confirmed, we can.
Awesome, thank you so much. So indeed, as I mentioned, IoT is a different kind of breed. So as we moved from the past, from the on-premises world into the hybrid, into the cloud environment, is that where companies, cities, entire governments, everyone else, and industries are building that new way to innovate their company, their city, their industry. So there's a lot of new opportunities that we can bring as an industry to support businesses. Of course, it starts always with the cloud, because as the cloud acceptance and the cloud connectivity is being that further into the space as before, then we can use and leverage that cloud connection to implement sensors, to implement smart devices, to help cities, help environments, and help people with a completely different way of approach and living. And as we all seen in the last few years, that from the past, there was pretty much nothing. Now, pretty much everyone is surrounded by IoT devices. As a silly joke, Your refrigerator can even tell you when there's something going on with your food if you want. So it goes really far. So there's a lot of things that we can do to progress from these smart devices into an intelligence that is not only used in the cloud or on premises, but actually offloaded from the cloud to these devices and then powered with artificial intelligence. Artificial intelligence actually leverage this to bring in vision, to bring in future transformations, to speed up that innovation even whilst we are working on this. And something that also is really growing fast is next to the physical devices and to implement and test and Q&A everything is to embrace the digital twins principle, to use, to create a living replica, to create a digital twin of what you are having into the hardware world to speed up your transformation. So there's a lot of different things in there when we talk only about IoT that help us to innovate. Now, what we have seen is that this is the good side. This is the positive side. This is the things that we love. Now, of course, it's like with every movie, with everything that we encounter, when we have good, we also have bad. So as we have that innovation, we of course need to be prepared for a different way of attacking it. There's a lot of different types of attacks into the industries, into the world these days, but the IoT world brings in a completely new type of breed of attack. Here, for example, we got three really easy examples that were happening globally throughout the years. We got the Mirai attack that pretty much actually almost brought down the internet for a day in Western US. So there's a lot of things happening by only infecting 100,000 machines. So the Mirai attack actually just touched really easily up into the basic default security settings that are pretty much always left alone from a simple IoT device. Right? Admin, for example, username and password, it's really easy. So there was a specific type of attack that actually infected 100,000 machines, only this, and they pretty much brought down the internet for a segment for a day. That was only 100K of devices. As you know, there are millions and a lot more devices on IoT. So really easy to get in there. I think it was in 2015, there was a casino that had a fish tank. And that fish tank was pretty much left alone on a security basis. And the attackers were really easy gaining access to the database of the casino through that fish tank connected filter. Because that filter device was actually connected to the internet to bring in statistics. And that was it. And then they get, of course, the more advanced attacks. There were, for example, attackers gained access into the critical safety systems of specific plants. Now, the advantage that they had, the defending part, is that they found out some really small gap into the attack so they could halt the attack before it really went south. Because the injection of the Triton attack was actually to gain access into the safety, the last defense mechanisms of these plants. So IoT is really cool. It's something that will not go away because the innovation and the speed and the performance that we can gain into the real life world is incredible. But the attacks are, of course, the same thing. So as within security, we always talk about kill chains. Now, when we talk and when we map kill chains up into the IoT department, then we, of course, have a kill chain for IoT, which starts with exposure. The exposure is actually where the attackers are looking for opportunities to gain access. So they want to gain access by, for example, insecurely configured applications. By exposing existing and publicized vulnerabilities of webcams, for example. There are a lot of sites out there where you can just go hunt and even look for webcams or IoT devices or something else that is just already in there with a specific vulnerability. It's not that hard to get in. So from the moment they have gained access, they have found a way to gain access, they will gain access. They will try to get into these virtual machines, into these Docker things, into the web applications, to gain access via credentials. There are a lot of companies that still have a lot of devices, either it's on-prem, cloud, or IoT devices, with the default credentials in there. These default credentials are always publicized on the web as a first step to change them, please, but they're still left alone. So from the moment they gained access into these IoT devices, they can start moving laterally. And that's where, from the dark side, the fun starts. Because if they gained access from one application, one device, one leaf, then they can move further. And from the moment they can start moving, they can go into the databases, they can go via IoT hubs or central components into different types of devices, and then they can bring operations to a halt. They can do specific things to cripple your organization, or they can just leak out data. So the kill chain model on IoT, high levelly spoken, it's pretty much the same sometimes as with default kill chains, but there's a really big difference when we talk about managing and securing these types of organizations and these types of infrastructure models. Now, right before we will go and look what we can do from Microsoft to allow for secure IoT work, let's look at the high-level IoT architecture that we have in the industry. So in the below, of course, we have the things. We have a lot of devices, we have a lot of things that we need to get IoT started. From the moment they have been set up and they are collecting, then when they will provide companies with insights to do actions. So in the left, it always starts, of course, with these devices. We have IoT devices. They can be leaves, they can be sensors, they can be, between brackets, dumb devices that can just collect data. They can be edge-based devices that already have a little bit of logic built in. And then they are connected to a cloud gateway. Now, of course, all these devices, they need to be provisioned. So in principle, as we do not talk about 1 or 2 or 3 devices, but thousands of millions of devices, we talk about bulk device provisioning. We need to have a technology that allows for massive device provisioning, not only from the IT security department, but starting from the manufacturer itself to allow for quick and easy access and implementation. Now, from the moment we have built out these devices, we have built out our integration, then we can start processing data. Then we can start the streams, start the network connectivity to allow for the data to be processed and stored into a storage environment. Now, of course, from the moment we have our data from these devices, we have all these things, then we can start analyzing and integrating it into our business processes. No matter what kind of infrastructure you have, it is cloud, on-premises, or IoT, there is always a business need to implement this. So, of course, from the moment we have that chain set up, then we will start working on these UI and reporting tools. Then we need to start visualizing what we have so the necessary actions can be taken and we can learn of what we have and then move further. And of course, to process in the future, we need a lot of intelligence to connect these devices and then be controlled. It's not just one thing that we need. There's a lot of components that IoT requires to keep on working and to provide us with that ease of work and that innovation capabilities. Now, if we look at all these components, then we look at a lot of different capabilities for attackers to get in. Now, I will focus today on the most important things to start from as a starting point, because these are the most exposed ones. We can talk days and days about protecting every little component of this entire architecture. This is not the case in here. We can do this afterwards if necessary. Now, the first thing that comes to mind when we talk about IoT and security is, of course, devices. Because these devices are actually just running out in the wild. They're placed onto homes, into lighting poles, into streets, into businesses. It's just everywhere where you look at it, you can encounter an IoT device, and that is actually just being powered on, having one network connector or even Wi-Fi, and just start working. So as they are publicly available on a physical level, we need to provide them with a lot of security built in. And when we talk about securing these devices, we actually high level have 7 properties to have a highly secure device. Now, of course, we need to have a hardware root of trust. As these devices are working purely based on data and connection, we need to, from the beginning, have a secure connection. And this secure connection is by default always done by certificates and by the secure connectivity that is built in. So we need to have them built in. Then we have, of course, have the need of defense in depth and small trusted computing base. We need to allow for whitelisting. We need to be sure that only the devices that we know and that we trust can connect to our environment via the cloud gateways. So we need to provide ourselves with a certain secure connectivity, a layered security in depth, together with whitelisting, and of course, based on failure reporting, and to have the capability of updating and to renewing these devices. We need to have a bidirectional connection. If we have any update or anything that is needed to push into these devices to renew security or another feature, we need to have that capability. So there's 7 properties to have these high-levelly secured. Now, what we have done throughout Microsoft, because there are a lot of different things in there to secure, we have built out something that we call Azure Sphere. Now, Azure Sphere is actually a high-grained solution to provide end-to-end security on microcontroller unit power devices. So when we talk about the MCU power devices, then we have the capability to work with partners, to work with silicon partners. So they build out the MCUs that have actually built into the silicon and hardware root of trust. And I will explain a little further on the line how we can do this and how we have that build up these partnerships. But this is actually pretty interesting, because if we have a connection, a partnership with these silicon partners, they can build in security that it cannot be tampered with. There's no layer upon this. So it is actually pretty much, yeah, unhackable, if I would say that word on a white and black thing. You have to have a really certain amount of trust to get in there.
It's
now,
dangerous to say unhackable in a cybersecurity presentation.
I know, that's why I said between brackets. You always can get in, right? But as it is built into the silicon, you have to have a lot of steps to get in there, right? But it is true. It's dangerous. So, as of course, the Azure Sphere comes with its own Azure Sphere OS, it's a Linux-based thing. We can have a secure connection. We can have that built-in OS that we can manage and update constantly. And of course, this is all monitored by an Azure Sphere Security Service. Now, I mentioned that I think already a couple of times. I will explain and show you what type of partners is that. This is indeed working for certified MCUs. This is not working with all types of MCUs, with all types of devices. So when we talk about this type of security, when we talk about this type of integration, we talk about 2 types of security based on Azure Sphere. So we talk about the greenfield and the brownfield. So when we talk about the greenfield, then we talk really with the silicon partners that have built out, like for example, the MediaTek, the 3620, I believe, chip that is actually having this connectivity, the security built in into the hardware. Now, of course, not all of them have this. So when we have the need to connect to these devices that do not have that integration into that connectivity, then we talk about a brownfield, and then we talk about partners, like for example, AVNet, that have the capability to integrate or to connect to existing hardware that is already in operation, and then to connect as an intermediate between that device and to the Azure Sphere service. So 2 types of integrations, natively or connected. When we talk about the native one, is that we have, of course, already a lot of silicon partners that are working with us either through the greenfield or the brownfield. For example, MediaTek has that chip, has that power integration to work natively with Azure Sphere. NXP, it was October 2019, I believe, that they announced that together with Qualcomm that they will build these chipsets to work natively with Azure Sphere. Not sure if they have it already, but it should be either already in there or down the line. And so we can work into the both segments with these partners. If you want to have a look at it in more detail, there's a lot of details in there, articles and even videos that we, for example, have worked with Starbucks or other companies to integrate and to show really cool stuff on this. So in principle, when we have that certified MCU, right, to go a little bit more in depth, then we have that secure root of trust. So by default, it is an ARM Cortex-M chip for real-time processing that has a network connectivity via the Wi-Fi in the first chips, but my personal favorite, powered by Microsoft Pluton. So Microsoft Pluton is actually, and I will explain a little later in detail, that security subsystem that allows for that hardware built-in, baked-in root of trust together with the necessary firewalls. Now these firewalls, of course, not firewalls as in the principle of a firewall. These are actually layers to prevent the components to go talk to each other, to connect while they shouldn't. So if someone would try to go into these chips or try to connect or send data in there that should not be allowed into the internal components of these chips, we have these firewalls, the layers of security to stop connectivity from the one to the other internally. So there's a lot of things in there that we can provide with these certified MCUs. And when I talk, for example, about these Pluton features, as I mentioned a couple of times, implemented in the silicon to have that hardware base of trust. So the cryptographic operations are actually built into the chip. We can have that through random number generator. So everything that we do on the encryption level is baked into that MCU core. Now, as I mentioned, these are, of course, decertified components. These are the components that are built in by, for example, MediaTek. If we have the brownfield environment, then we have that Guardian module. And these Guardian modules, for example, AVNet is a partner of us, works with them, has built them, and then they can connect to, for example, an espresso machine. And they serve as an intermediate to connect to the Azure Sphere security servers or the A3S to have that connectivity, to send out the app data and telemetry, but also to provide these connecting for app and OS updates. So two types of things, natively or connected. Now, moving away from the devices, moving more into the cloud gateway and the provisioning environment, is that we have to have the capability to have a connection between these devices and to have that management and end-to-end security on connection. Now, for this one, we use an Azure IoT Hub and the Azure IoT Hub DPS or device provisioning service. So we have the capability to have an automated provisioning starting either from the vendor or from yourselves and manually automatically, and to have that capability to securely automatically provision these IoT devices and immediately integrating into IoT Hub, where we then have a security overview, alerting, and everything else. Now, within the Azure IoT Hub, we can enforce, we can allow for IP white and blacklisting. We have the support of X509. We can, of course, have the firmware and software updates. But of course, next to this, and I will explain this a little later, support and connection to the Azure Security Center to manage the entire security of your data centers together with your IoT in one pane of glass, because there's never alone IoT. So the Azure IoT Hub allows for bidirectional secure communication, to send telemetry, to allow for device management, to have that scale to process billions of messages, and to provide end-to-end security. So if we look a little bit more deeper, is that we have that at-a-glance security overview. We can view into the IoT Hub if there are any device recommendations, if there are any devices that are that are not being built in securely, where we should think that we have to have a different configuration. We can, of course, configure also the custom alerts based on your use case, based on your environment. Looking one step further, next to that build device provisioning, as I mentioned, is that we have to have a secure but automation process into that provisioning. So as we have the DPS, the device provisioning service, we allow for all these sensors and edge devices to be brought into the environment automatically and securely, and then automatically being able to be managed. If you should have multi-tenants in your environment, we allow also for multi-tenancy. I'm not sure if you have the need for multiple IoT hubs or something else. For example, multiple regions, we allow this too, especially for the larger environments. So we have our devices set up securely. We have that connection into the cloud and we have provisioned them securely. Then we can start managing them based on a security level. Now, for this, we use the Azure Security Center for IoT. Now, the Azure Security Center for IoT is actually a component and built into the general Azure Security Center. And the Azure Security Center, which I will show you a little later in real life, is that single pane of glass that allows for the complete view of all the policies, all the specific recommendations based on security hygiene, and of course, all the threats that are happening in real life into your environment. So Azure Security Center, cloud-based environment to connect to your workloads and to your IoT devices. Now, looking at it in a little more detail, is that we have, for example, if you have, for example, our Sphere devices, IoT Edge Security Module, and of course, our field devices and gateways. These ones, for example, are then powered by security agents, moved into the SDK, moved into the Azure environment. Into the Azure environment, then the connection is being made to the compute network, the IoT hub that allows for the integration. And these solutions, then they will feed out into the security analytics of the environment. Now, of course, security analytics, as we have it, is of course not only based on the local technology, but of course based on local and global threat intelligence as we have them. It's then being pushed into that log analytics platform. So all the data that we have is then being kept and being stored to be exported to do something else with if needed. But when we talk about this use case, is then of course all the details and all the data and all the analytics that we have is pushed and moved into the Azure Security Center, where we have these dashboards to provide a visibility, where we have these actionable security recommendations, and where we allow for security in principle, mapped, of course, with the IoT stuff. So the Azure Security Center for IoT is working as a component to provide that end-to-end connectivity and security. Into the world, we have our edge and our devices. They connect over the internet. All that data and all security, the secure connectivities are then pushed and managed from the IoT hub. And all that data, security related, is moved into the Azure Security Center. Now, as I'm of course only talking about IoT, the Azure Security Center of course has also that visibility and the control and security of your default workloads too. Moving away one step from the IoT environment is that when we talk about a business, businesses and enterprises do not only have IoT. They have a lot of different technologies built in, and of course, not only Microsoft, but a lot of different vendors working into their environment to provide end-to-end security, starting from the identity, moving to the internet and the IoT. Now, as we have processed and seen and evolved within security as Microsoft, we have also acknowledged that we have that capability within the cloud to provide a holistic overview based on Microsoft and based on an integration of all different other vendors and partners that are possible to integrate with. So we have built out our own SIEM and SOAR solution that has the capability to connect to our own security technologies and security technologies from others. So we can import we can include and integrate different data sources, move them into our SIEM and SOAR solution, provide automation integration with different types of repositories and security telemetry for companies and enterprises to allow for that kind of forensic and security operations.
But it could be useful just quickly explaining again what SIEM and SOAR is really.
Of course, my pleasure, and apologies. So a SIEM and a SOAR, high levelly spoken, is an incident and event management solution. If we should translate it into a little less technical terms, is that every company has between 20 and 90 security solutions or technologies in place to have security into their environment. Now, all these different types of solutions, they have their own security events, their own security alerts. For example, if you have an endpoint protection solution next to an email solution, next to a firewall solution, next to a cloud solution or on-premises identity and infrastructure solution, you already have a lot of different solutions natively for security. And then we can talk about the default events, like when has someone logged on? When was there a DNS request for something else? Now, if we translate all these data into something what we call security, there's a lot of it in there. So companies have challenges to translate and to find specific types of attacks or visibility when something bad is going on. Now, for this reason, the industry has built out a SIEM solution. So a security incident and event management solution. And that solution has a capability to connect to all these data sources. It has a capability to connect to your endpoint solution, your email solution, your cloud solution, all these types of solutions that has an interest or an integration to security. And from the moment it has ingested all these different types of telemetry, you as a security responder, as a security team, you can use intelligence and use the power of that SIEM solution to map these different types of solutions together to start working. And that's the first thing. Now, when we talk about, for example, Sentinel, is that next to that SIEM component, we have also the capability to automate it. So we have the capability to provide automation and leverage that cloud intelligence, which we call a SOAR solution, which is called security orchestration, automation, and response. So from the moment we moved into that SIEM component to ingest all that data, then we need to orchestrate and automate it. So we don't want to do everything manually. For example, we can build out playbooks. If X has happened, combined with Y, Z, and 1, then we want to automatically do X, 1, or 2. So we can automate and we can respond to what we have discovered. Does that help on an explanation on a SIEM and SOAR solution?
Yep, thank you.
My pleasure. So what we have done is we have built out that cloud-based SIEM and SOAR solution to integrate not only with Microsoft, because we of course acknowledge that there are a lot of different security players in the field that are really important and really well versed to protect companies. So let me provide you with a little overview of what we do actually in the wild. So of course I don't want this. So I hope you can see my screen right now, Security Center.
Yes, we can.
Awesome. So as I mentioned, the two components to provide a single pane of glass is to start with Security Center. Security Center is that single pane of glass that integrates and connects to all different components. For example, from the compute and apps into the networking, into the IoT environment. So we ingest all that data to provide configuration and policy capability, but of course to provide threat protection. We need to protect our infrastructure and our workloads. So we have in here our overview, where we, of course, for example, can see our secure score. Now, secure score is actually something that is really interesting because there are a lot of different security toolings, but all these toolings have their own configuration and feature sets. Now, Secure Score within Security Center provides us with that visibility. That, for example, advanced data security should be enabled on your SQL servers. And for us, this is completed. So there are none unhealthy resources. On the other hand, we can see, for example, that there's a vulnerability assessment that should be enabled on my SQL servers, which has an automated remediation capability. And we have seen that one SQL server is actually not meeting that compliance. So based on a technical level, and I'm really meaning the technical, the features and the configuration capabilities, we can view, as we have that connection into either the IoT devices or the workloads, if there should be something that is actually not healthy or not configured correctly. And then maybe it should be fixed immediately, or maybe there is a reason, a technical or business reason why we cannot fix this. But we need to start with the beginning. We need to start with viewing how it is being built. Then something else that is actually pretty much important is that when we talk about companies, is that we of course start next to the technology, we talk about regulatory compliance. So there are a lot of different regulatory compliancy statuses that we can view. If we should be mapped or audited on them, we can provide them with these reports and visibility if something should be happening. For example, the Azure Center of Incident Security 110 is showing that actually we don't have MFA enabled. So Security Center allows us to provide with that visibility if everything is connected, what's going on, is it good or bad on technology on our regulatory compliancy, and do we have any specific alerts? We can view these alerts. We can view them if we want into detail, and then verify if something else is going on that we should know about. And this is across the workloads, across the IoT devices. So as mentioned, Security Center, for example, when we talk about that IoT hub environment, is that IoT hub, as I mentioned before, is a critical component as an intermediate to connect between the edge and the leaves into an environment, so we can immediately see if there's something that should be fixed or being built. Moving then away from that Security Center, from that operational management dashboard, from the workloads, then we move into that SIEM and source solution. Now, SIEM and source solutions, I mentioned, what we call Sentinel, has a capability to not only connect to the Microsoft tooling, but has a capability to connect to all sorts of tooling and all sorts of solutions. So we have our data connectors. And these data connectors allow us to really easily connect to either solutions of Microsoft or solutions of, for example, AWS, Palo Alto, Fortinet, or custom components. And then we can, for example, just connect to Amazon. We can connect to the Azure Security Center. And that is something that I also wanted to show you today. As I mentioned, Azure Security Center for IoT. It's still in public preview. Then we have the capability to connect to that component to also not only integrate our IoT security-related data, but that security-related data of IoT is then automatically correlated and integrated into playbooks, into our incidents. One practical example of this, if we should have security based on IoT, we have a lot of different components out there. Now, from the moment we start working on enterprise scaled or a more mature scaled security process, is that security process does not care alone for IoT or endpoints or clouds or identities. It needs to be taken as a whole. That's why, for example, we have built out all these data connectors, but also integrated the IoT part. Because the IoT part will be an essential part of an enterprise in total. It is not a segment that is isolated. So it needs to be taken care of, integrated. So from the moment we have built out our data connectors, All the data that we can see separately is then built in here. Now, these are, of course, all events and alerts. So we can view, there's a lot of them, as you can see. So as a security operator, you are never able to go manually across 42.4 million events. So that's one of the reasons why we, for example, have built in, of course, the alerts, but also automatically baked in incidents. And these incidents are then actually built out due to our artificial intelligence capability and our playbooks and our automation to provide you with that visibility. So you do not have to go over all these different types of events and alerts. We will automatically scale them down and we provide you with a real shorter list of what you should investigate together with the high, the medium, the low, and informational types of severity. Now, for example, let me take an incident that in here, block download based on real-time content inspection, for example. So if I click on this incident, I can go and investigate. When I go and investigate, I can see automatically all is happening. So I got in here that incident that was being created. I can see the user, Megan Bowen. Now, Megan Bowen has also other types of alerts that we can view. We can see that there are specific alerts based on Microsoft OneDrive, and we can see an outside IP address that is also being provided into that incident. So if I should go deeper, I can, for example, go into the Office activity IPs for these accounts, or just want to see the related alerts. So I can click on the events, and then it shows me all the different types of alerts that are mapped to Megan Bowen. So automatically that query that you can see in here is being created for me. And then I can go in deep dive and investigate, if I want, into detail what's happened. And then we really go into that forensic, into the investigation part of it, of things. But this is the interesting part. Sentinel is being built to integrate Microsoft and non-Microsoft security toolings to automatically provide you with visibility and correlate events into incidents, and allows you to build your own playbooks, customized based on your own needs of the enterprise, together with analytics. To give you one example. Now, again, this is a high-level overview of what we do on this part. But if we should return to this environment, into the overview, is that we can, if we relate it back to the IoT part, is that we need to have, as an industry, as a company, or an enterprise, a city, or a government, we need to have as much layered defense on IoT as possible. So it starts with having security built in into the device, from out an edge, a leaflet, or into the center component, into the hub. Then we have the visibility to see our security posture. How are we doing? If we have integrated, if we have embedded, if we have deployed our IoT environment, how is it being built? Is it secure or not? We need to have all these things into a single pane of glass. Either is it IoT or cloud or on premises, to allow for the analysis and the management of the security posture. And when we have that complete visibility, then we need to have the capability, if there are specific devices that should be compromised, as we are talking about millions of devices, we have to have the capability to block automatically or manually these compromised devices. One practical example, if someone has tried to tamper with an IoT device and has been trying to decrypt connection or information, or try to compromise from that device into a lateral movement, other types of devices, we can detect if devices are compromised, so you can immediately block them. So the lateral movement or the injection of attacks stops. Of course, for the next period of time, we need, of course, a constant health monitoring. Because, again, A healthy device is okay, an unhealthy should be blocked. We can find threats across the environment, and then we can move further, as I've shown, into a SIEM and source solution like Azure Sentinel to integrate IoT next to the identity, next to the endpoints, the servers, hybrid environments, and third-party components like a firewalls, like a network protection. That's basically the idea, to provide an end-to-end security on the IoT. Now, I moved not that fast, but I've tried to keep a space to have questions and remarks. Are there any questions or remarks? Or
there are not yet any questions coming from the audience. So, but in any case, you can further continue. But I do still have a couple of questions. So, once well, you can either finish the slide deck, or we can take them now as what you see best fit.
I finished my my deck because I always wanted to have a space for the discussions.
No worries at all. Okay, so just another request to our participants, if they have questions, that yeah, now I see it. Thank you. That's pretty clear. What that means. So thanks in any case, Bart, for the clear and good overview of what Microsoft is currently doing in the space. I think in the first place, of course, when we today look into industrial cybersecurity, there's of course quite a number of what we can call legacy. And for us, in our case, legacy is everything that is not yet connected as such. Yes. So that needs to be additionally provided with some form of connection, or that needs to be hardwired to be able to make it connected. So the question there is to your knowledge, is Microsoft doing anything towards that respect? So we know that we can, of course, connect traditional systems either through something like digital sensors that transform analog signals into something digital. So that's really hardwiring or putting it on top. Basically, some of the things that we do within our TRIF activities. Yes. Or we can link directly through a serial port, or something less advanced than the things that we have, like Modbus, in order to get some data out of a device. But and then we can move it further towards connections made via Ethernet. Then we can see OPC, OPC UA. So, yes. Question basically, is Microsoft doing anything in that space as well, potentially also with Sphere, that you can see at least?
Yeah, so indeed, as also explained and shown, so thank you, it was a great question, by the way. We work in the Sphere department, so in the environment of Sphere, Azure Sphere. Predominantly for now, we are working on internet-based connections. So indeed, IoT or IoT devices that have a connectivity to the internet. If your internet connectivity should be failing, there's no problem. We can, of course, cache everything. It keeps on working. But intrinsically, it needs to have something, either the device itself or the device that we have connected to as an intermediate to have that connection to Azure Sphere. So for this part, if we want to have security, we need a component, we need an integration into the internet. Now, what you also might have seen is that we also announced, for example, as I call it, the partnership on integration with CyberX. And CyberX is then more based on OT or non-specific types of internet-based connections and devices. We have ourselves also been investigating capability and the possibility to do more intrinsically without CyberX on the non-connected devices, but I'm not at liberty to say right now if we have moved anything forwards into that environment.
Yeah, so I think in terms of the connectivity to legacy and the use of CyberX, that's maybe some topic that we can further elaborate on at another point in time. In any case, but in terms of can you see from, for instance, from the Sphere developments? I actually have a Sphere here with me. It's actually quite a nifty device, I think, to be honest. This is one of the demo devices that I received from when we were still capable of running around in the world and trying to seek people and meet up with people. So it's one of the systems I received from the and as you can see, it reads the MX chip, Microsoft Azure IoT. So we've been experimenting a little bit with this one. It's a great and it's a super invention in any case. We thank Microsoft for that, and also because I'm not sure that you actually said it loud and clear, but it's an open source technology. Yeah? So Microsoft licensed it for any developer to be used, and I think it's great for us to start some development on. So are you aware of anything like this that maybe connects to those traditional legacy systems, or is it something that's still ongoing in terms of its development?
So yes, we ourselves have not built something quite to integrate with systems that have not native connection to this one, but we have the capability to a partner like AVNet. So AVNet has that digital guardian or that guardian capability to work between these legacy devices and the enterprise environment. Yes.
Okay. Yeah, and so then the question is, in that space, do you know, or who is actually following up within Microsoft the different developments that are happening on this domain? Because I think in our world, the different partners that we work with would be definitely very interested in figuring out, okay, which partners can they start using to integrate and to get to an end-to-end security environment as you are suggesting. So if we can start using those types of partners and the technologies that they propose, it would actually be very helpful for us. So, but maybe there's a specific web page that you can share afterwards or so, where we can find those different partners.
Yeah, I will certainly follow up on this one, because indeed, and thank you also for mentioning this, because I have not mentioned this before. That it is indeed completely open source. It is completely Linux, right? We acknowledge. We really acknowledge that.
The greatness of Linux.
Exactly. I was really looking for that one word, because it's an open source world. It's not a locked down, closed world.
Yeah.
So of course there are a lot of partners working with this.
Okay, great. So we have a question coming from Daniel. The IoT devices connected to the Azure security platform, are they automatically protected and safe? Or do we need some highly specialized people that should try to connect them, should try to manage them? So that's I think a relevant question. So if we connect, and I think that's something that we actually see quite often in an industrial world, organizations are just putting in additional devices, and then in many cases they are being equipped with a number of self-notification tools, as you know. And those, of course, are from a security perspective not really the best way to do this. So, what about the IoT Sphere, Azure Sphere devices, or how does the security center and maybe also Sentinels reach out to the devices in the field and understand whether they are secure or not?
So it's a great question. It actually starts with secure provisioning. So secure provisioning is really important because it starts with the manufacturer. So the manufacturer has a capability to automatically register the device. So we can register these devices, and then from the moment these devices are registered, these are then built in and pushed into your environment. And that environment, indeed the Azure Security Center, or for IoT, together with the components, they can automatically see if these security recommendations, with secure score, something else, if that device is being set up or configured correctly. So we need to make security as easy as possible because there's a lot of different types of security. So there is auto provisioning capable. We have an SDK to allow for automatic provisioning and configuration of these devices. If we should, for example, translate it into a Windows environment or a server that you want to integrate or add to the domain, you want to do it hardened or secured from the beginning. And that's the same principle for IoT devices. Start with the right registration, start with the right auto provisioning, with the right configuration capabilities, and then review them because they can change.
In terms of the further developments that you can see now moving forward, I think there's actually quite a lot, of course, happening in the space. We are trying to understand what the challenges are in relation to industrial devices. We're also trying to understand how we can use, and that was one of the topics of this morning, AI technologies. We are trying to improve ourselves in using the mechanisms, as you mentioned earlier on, the security orchestration, and trying to figure out how we can actually manage on the basis of scenarios different challenges in relation to security. Now, none of those developments, if you like, has really reached that the industrial world quite significantly. I think that we see a lot of good developments, but overall, the industrial cybersecurity world, I think, is still lagging behind for quite a number of years. So, what do you see that from within Microsoft you have as plans in trying to further target this market, and maybe like you've done also in the IT world, being able to facilitate us with some of the better technologies out there, and trying to help migrate us into an online 365 world. Is it going to be something like 365 for my CNC machine, or my industrial weaving type of environment, or something of a kind?
I surely hope so. It's a good remark too, because as you saw like, let's say 20 years ago, 15, 20 years ago, when we had IT like we have IoT now, and 20 years ago, IT departments and IT environments were exactly the same as we have right now. Completely unmanaged, a sprawl of different types of OS configurations, completely unsecure or either too secure. That's exactly what we have right now. So the IoT world, the ICS world, is built on productivity. The main use case that we see right now in that environment, into these production environments, are really meant to have everything running. So that's the challenge that we face today, because they have two intrinsic challenges with them: no connectivity and as static as possible. But as it is as static as possible, the challenges of threats and attacks are, of course, pretty much really heavy, because attackers can get in there. And as I mentioned indeed in the beginning, and it was between brackets, but that's the challenge with having digital conference, everything can be hacked, everything can be broken. So within Microsoft, we have really built out these first steps already to provide a little bit more integration and security by default end-to-end for IoT devices. We are really making steps, for example, with the acquisition of CyberX, to move further, to provide hopefully that platform to rule them all, right? To have that platform, that integration, to provide, whether it is internet connected or dark or non-productivity based, to have that sensor security based stuff. I really want to have one too. But we're having a lot of departments and people focusing within Microsoft, not only on security, but also on that department.
All right. Bart, I thank you very much for your contribution, and to showcase also a little bit of the Security Center, to give us indeed the perspectives of how we should be able to see, let's say, also the future in terms of devices and device management. And I do firmly believe that the 7 security strategies that you put forward are also the ones that we are living by, and that I also regularly do use to advocate to people on how they should really think about security. So it's really end-to-end. It's about security monitoring, and it's about making sure that we can build a trusted relationship with not only device, but especially also everything that's lying behind it. So thanks a lot for that. I'm definitely hoping to see you back again also next week. We've invited you also for our TRIF activities, and hopefully you'll be able to share some other viewpoints, but then more from, let's say, the manufacturing perspective in this case, and maybe indicating where some other developments are happening within Microsoft in that particular space. So thanks a lot for that. With this, I would say trying to get my screen back here as well, and hopefully my system is not blocking me here. In getting back to my agenda for today, is that we have another series of webinars planned during this week still. That's going to happen on Thursday. We'll have another session on identity and access management, another one of those big structural and architectural fundamentals of what security is all about. And at noon, we'll hopefully be having our GDPR panel after 2 years of GDPR. It's a good moment to do a bit of state of the art at the time, and I get a good perspective on what's there today and what's still further to follow. And then next week, we'll have an interesting NIS webinar as well, in this case from Ralph Bansmuller from G Data Cyber Defense, who's also with us this morning. So we make actually a switch between the two of you to some extent, and we'll be focusing on ransomware, which is of course one of those challenges that that we've seen in the domain of industrial cybersecurity that's really challenging those industrial companies quite heavily. So with this, I would like to thank you again, Bart, for sharing and for attending and for presenting. And thanks again also to Microsoft to be of support. And I'm looking forward to seeing you definitely next week and in our next sessions. So with this, have a good afternoon, all of you, and see you next time.
Goodbye. Thank you so much for having me.
Bye-bye.